I'm Sebastian Sanchez. I'm part of Boardwalk Robotics. We had presentations earlier about Nadia. And today I'm going to be talking about the feet. You saw already a carbon fiber foot that we had, but more about adhering soles to the feet, which is something that I don't think people talk about very much. Do Lego robots even need slippery? It's distracting, sorry. Alright, do Lego robots even need grippy feet? I think like we like sliding, as you saw that guy sliding, I think the robots would like it too, except the controls engineers really don't like it. The most dynamic robots we have around, Atlas and Digit, they have grippy feet by just adhering a sole on, but that method we've had issues. So we use our robots pretty hard in our lab. You might say mistreated. The robot soles fall off all the time. This is DRC Atlas, which we have and have had for like 8 years. And it's a huge hassle. It has custom soles made by Vibram. It's a huge hassle to glue them on. And as you walk over cinder blocks, etc., it's pretty hard on the foot soles. The same thing happens with Nadia. We run it hard. I think the foot on the right is the one that Josh had to show around, and the soles just fall off. So what do traditional shoemakers actually do? Sneakers usually are cemented construction or injection, where the foam is adhered directly to the upper, but I'm more focused on like traditional footwear, so boots, where they actually mechanically sew the upper to the lower. So I try to do the same thing, thanks to YouTube for like even giving me this knowledge, thanks to the pandemic. Our initial approach was to make a custom sole out of Smooth-On, which is portable, castable polyurethane, and then glue it and sew on. So the left is the mold that I actually made, which, here's the pointer. Here's the sole the sole mold that I 3D printed. I cast it and then I glued it to the feet, which looks like this, and then it went on the robot and it looked like this. It did okay until I gave it to the controls engineers, and this is what happens. We treat our robots really hard, and this is what I got back. So I gave them this pretty pristine feet, and now they're delaminated with chunks falling off. But you can see that the mechanical part, which is the sewing on, actually stayed. So all of the threads are still there. We also tried to, in the casting process, like mold it directly to the foot sole itself, and then Nadia thought it had erasers on its feet, and then it just crumbled off as it walked. Our current approach, which is what I'll show pictures at the very end, is to get actual Vibram sole material to use in boots, to score it with a laser cutter, and then punch holes and cut it out. Then glue it with traditional glue, and then sew it by hand using a saddle stitch, which is what they use to make like traditional leather goods. That means that it looks like this. It's pretty much similar to exactly the same to the first image I showed. And then we hand it off to the engineers, and have it do funny moves. And again, treat it really harshly. We did a lot of tests in the last 3 months, so this was in March. The last 3 months, specifically to have data and videos for this conference, and you can see that the robot's foot has held up pretty well. The tread is still there. Most of the threads are still there. The white tape is actually for visualization, so that the robot can see its feet. And so that's not like that it got banged up. But it's not without its faults. There still is a little bit of delamination, and some of the threads did fall off, as you can see here. For the most part, it's great. Another thing that happens that we've noticed is that it really depends on how dirty your lab floor is. If your lab floor is real dirty and real dusty, the grippiness, you can have the best Vibram sole, the best Nike sole, it doesn't really matter. you can't really, I think a robot has a hard time telling like is it slipping or like how grippy the foot is. And thank you to Dex for making the funny videos, and Josh for helping me with the feet. Any questions? Yes.
So you seem to be having two issues in your talk. One is slippery floors, and the other is treads coming off.
Yes.
Which is
I think
I don't know which is the greater issue.
The tread's coming off. The tread, because we can go and clean the feet. You know, just take a brush or take some isopropyl and clean the feet and sweep up the floor. But the foot coming off, we just now got a lab technician to actually do these repairs. But before it was just us engineers fixing all these issues, and we don't always have time to go and fix them. And so the controls engineers would just get duct tape and duct tape it around. And that is the biggest issue. Like, it creates bad bad runs for people, and it just slows people down. And then, so the cleanliness thing can be fixed. We do have to periodically sleep. We use cinder blocks all the time, so it creates a lot of dust. That is another issue. Yes?
I just wonder, how long does it take you to make one sole? Because like that's a pretty tedious process of
Unfortunately,
by hand.
yeah.
Like, is there a solution with like staplers or
I haven't tried staplers because like the upper of our foot or our shoe is basically really stiff material. So whether it's carbon fiber or aluminum, you can't really like staple it very well. It takes about 2 hours to do. The last time I did it, it took me about 4 or 5 because I had to like figure out how to redo it for the vibram soles. So as long as you have the process down, it takes about 2 or 3 hours.
Just to add on that, do you remember how long it takes on the DRC Atlas to change the soles?
It takes 4 hours only to glue, and then it takes somebody with isopropyl, a wire brush, a scraper, more hours. So they use super strong glue, and it delaminates, but then you have to have the surface completely clean. So then it takes people probably like a total of like 8 hours to completely put new foot soles on DRC Atlas, which is a huge issue. Yes.
So I remember at some point there was some collaboration between shoe companies and Pirelli. I think that they make the tires, and I was wondering if you could like do some kind of collaboration with kind of people that have expertise in other kind of fields that in this aspect might have some crossover.
Yeah, we're a small team. I mean, a lot of our actual mechanical engineering team is here. And so we're not like, when we've talked to big shop companies, if they're like, you're not going to order more than 100, if you have a very low quantity, they don't really care. Like, we don't have enough reach. If we were Boston Dynamics, sure, but we're not. And we don't have enough of the reach where like them spending their engineering time on us would like benefit them. Yes, in the back.
We did a similar thing, and we just asked our cobbler. He did it for us.
Yeah?
And he's basically sewed it on. They have good tools.
Yeah.
Find a cobbler.
Jesper. Oh, here.
Did you consider like a slide-in and clamp mechanism?
Like to slide it in and clamp it?
Yeah. Like the whole sole instead of just like sewing it in.
Yes, but that would increase the height, and we're already annoyed with the height of the foot. We did think about it more of like a groove that you'd slip in, and decided it'd be just more simple, not to make, but more like simple as a thing to sew it into place. Jesper.
Your robot was way lighter to still have this problem.
Yes, I think so. I think if you give controls engineers anything, they will break it for you. Yes.
Do you hate control engineers?
No, they're my friends. Thank you.